In this presentation, we will study Signum function. Signum function is represented by SGNT. Signum function is also known as sine function. Signum function is also known as sine function, and we got this word signum from sine. Signum stands for sine in Latin. Signum stands for sine in Latin. Now, why we call this function sine function? What is the reason for calling it sine function? We call it sine function because it tells us sign of real numbers. I will first draw the number line. Let's say this is 0. When t is negative, this means when t is less than 0, the sign of numbers will be negative, and the signum function is equal to -1 when t is less than 0, representing the sign of numbers. When t is equal to 0, there is no sign, so signum function is simply equal to 0 when t is equal to 0. When t is greater than 0, this means numbers will have positive sign. The signum function is equal to 1, representing the sign of numbers. Now we will draw the waveform of signum function using this definition. When t is negative, signum function is equal to -1. When t is negative, signum function is equal to -1. When t is equal to 0, signum function is also equal to 0. And when t is positive, signum function is equal to 1. When t is positive, signum function is equal to 1. So this is the complete plot of signum function, and you can see at t equal to 0, the plot is discontinuous. The plot of signum function at t equal to 0 is discontinuous. The signum function at t equal to 0 is discontinuous, and because of this reason we cannot differentiate signum function at t equal to 0. Therefore, we cannot differentiate signum function at t equal to 0. Now we will see few examples based on signum function. In the first example, we have signum -3, and it is equal to -1 because signum function tells the sign of the number. The sign is negative, so signum -3 is simply equal to -1. If we have signum 7, then it is equal to 1. If we have signum 0, it is equal to 0. And there is one homework problem for you. In this homework problem, we have signum pi -3, and you need to tell me whether signum pi -3 is equal to -1, 0 or 1. Once you have your answer, post it in comment section. Now we will discuss various properties of signum function. In the first property, we will find out relation between signum function and unit step function. We will find out relation between signum function and unit step function. Signum function is equal to -1 when t is less than 0, and it is equal to 1 when t is greater than 0. I am not considering the signum function at t equal to 0 because we cannot differentiate signum function at t equal to 0, and we have to differentiate the result obtained in property number 1. Now I will add 1 to the signum function. So we have -1 plus 1 and 1 plus 1. So at t less than 0, we have 0. -1 plus 1 is equal to 0. And at t greater than 0, we have 2. And we know the definition of unit step signal ut. It is equal to 0 when t is less than 0, and it is equal to 1 when t is greater than 0. If we multiply unit step signal by 2, we have 0 when t is less than 0, and we have 2 when t is greater than 0, which is same as this result. So we can write 1 plus signum function is equal to twice of unit step function. I will write this relation again. 1 plus signum function is equal to twice of unit step function. So this is the relation between signum function and unit step function. Now we will find out relation between signum function and unit impulse function. In the second property, we will find out relation between signum function and unit impulse function. For this, I will differentiate this result. On differentiating, we have 0, differentiation of 1 is 0. Then we have differentiation of signum function with respect to t equal to twice of dut by dt. And if you remember the last presentation, we proved differentiation of unit step function is equal to unit impulse function. So we have differentiation of signum function equal to twice of unit impulse function. So this is the relation between signum function and unit impulse function. In the third property, I will explain one more way to write the signum function. When signum function is having the argument equal to t, then we can write it as mod t by t when t is not equal to 0, and it is equal to 0 when t is equal to 0. You can cross check this. Let's take t equal to minus 3. So signum minus 3 is equal to mod of minus 3 divided by minus 3, which is equal to 3 by minus 3, which is equal to minus 1. And the result is true because you can see the sign of number is negative. Let's take one more example. When t is equal to 7, signum 7 is equal to mod 7 by 7, which is equal to 1, and the result is true because sign here is positive. So we can represent signum function like this also. Mod t by t is not valid when t is equal to 0, because when t is equal to 0, we have mod 0 by 0, which is equal to 0 by 0. According to this 0, we have 0, and according to this 0, we have infinity. So the result is not defined when t is equal to 0 if you use mod t by t. So we have mentioned when t is equal to 0, signum function is simply equal to 0. So you can use this definition, or you can simply use this definition. Both will produce the same result. Now we will discuss the last property, the property number 4. In the fourth property, if you differentiate mod t with respect to t, it will be equal to signum t, and this is true only when t is not equal to 0. So this is all for this lecture. If you have any doubt, you may ask in the comment section. There is one homework problem in this lecture. You need to find out signum pi minus 3. Once you have your answer, post it in comment section. I will end this lecture here. See you in the next one.